Well, hi, good afternoon, everyone. Thank you for joining today. Today's Developers Corner, we're going to have a little chat about life and gRPC. And joining me today is our usual cast of suspects, but Jeremy and Eric, you want to introduce yourselves?
Hey, Jeremy Davis. I'm an architect at Red Hat. I've been here for about 13 years and have done a lot of app dev stuff.
Yeah, and I'm Eric D'Andrea. I've been Red Hat for a while. I used to work with Rob in a different team. Now I've moved over as a dev advocate and loving life since moving out of Rob's team.
Oh, thanks a lot. Oh, wow. Wow, the darts started flying right off the bat. And it's recorded too. So wow, I should have my manager watch this. So what is the genesis of this discussion, and how did we get here? Is that I personally work a lot with app dev folks, and we get a lot of questions about, especially when doing microservices approaches or hexagonal architectures, about what kind of API design should I do? Should it be RESTful? Should it be gRPC? Should it be GraphQL? Should we be using Kafka? All the above. How does that fit? So, in our last episode, we gave some rules to the road about doing REST, and today we're going to focus on gRPC and when to use it and why we would use it, and we're going to examine it a little bit from the Java perspective in natively, and then we're going to show you how much easier life could be if you're actually using Quarkus to do that with Java. So we will explain some things all about it. So if you're not a Java developer, we'll go into some depth about that and give some best practices near the end. But the main focus here is going to be on the Java perspective. So with that, I don't know, Jeremy, do you want
to? We can kick off a little bit. Do you want? We can talk a little. Why don't we do a little bit of slides first, right? And then we will very quickly go to some code here. Right, so we introduced ourselves.
Sure.
Talk about that. And you want to maybe do a really quick overview of the difference between gRPC and some other patterns, API ways of making APIs, and then we'll build some stuff with gRPC.
Sure.
Can you guys see my screen, or is that not?
Nope.
No. Okay. Right. Try that again instead of just sitting here. Okay. Share screen.
It's the moderator's going to bring it into the. There we go.
Yeah.
Okay. There we see it.
It's a little fuzzy.
A little blurry there, Jeremy.
Okay. What? Oh, is that any better or no?
Oh, that's much better. Okay. What'd you do? You wipe the screen down with some Windex or something?
You're not actually looking at my screen, right?
Sure. So last time we talked about REST and what is RESTful, and how it was resource-based. And quite honestly, most of the APIs that we're seeing nowadays from an external in to your code are probably going to be RESTful. But that's resource-based. There's really no standards for that. And there's really, we're going to talk about the comparison with REST later, but one of the problems there is that even if you're using OpenAPI or Swagger to develop stuff, it's really not a kind of code first experience. And gRPC is the polar opposite. It's it's about high performance, and we'll get into what that means. So it's not just saying high performance. We'll give you the definition of that, but it's really about those kind of mechanisms that people are probably familiar with. So if you're decomposing some kind of monolithic architecture into components, you're probably doing direct calls today. And as you decompose those components, both from a performance perspective and the perspective of it looks like that component is local to me, gRPC is a kind of a natural fit there. GraphQL, again, that's a query language, but that we're going to go into that comparison maybe in a future episode. But I don't know, Eric or Jeremy, you got anything to add to that? I will tell you which one I hate the most, and that's the one at the bottom.
So yeah, everybody hates it. Yeah, GraphQL. I don't see GraphQL as that's really a different animal, I think, and makes a lot of sense for front end services for sure. But I don't really see it to be too much of a comparison between REST and gRPC.
Yeah, I typically what I tell people is, if you're starting to decompose stuff, use REST as your external facing API and try to use gRPC internally. I think what a lot of people do is they think they're doing microservices, so they have to do REST and create all REST endpoints, and then they discover that there's a performance hit on that. Shane in the comments is saying WSDL is a triggering trauma. Anybody that's done WSDL and had to do the XML to define the data, and then you get into all the schema stuff, and then how do you handle exceptions versus errors and all that other stuff, or even something really special like maybe you're doing CXF or something like that, and doing some magic in Maven in order to compile the WSDL together and do some SOAP stuff. Oh, it was horrifying. I couldn't stand it. But what was SOAP trying to accomplish? So do either of you guys remember the Don Box in Barcelona thing? If you Google for Don Box, SOAP in Barcelona, you'll see one of the very first SOAP discussions was Don Box from Microsoft. Well, I don't think he was at Microsoft at the time, but he got wheeled out on stage in a bathtub and gave a talk, one of the first talks about SOAP from a bathtub on stage. So it's pretty classic. You should look for it. But what were they trying to achieve? An actual RPC kind of mechanism on the web, right? Because you were moving from, development on Windows or something, and now you're doing something on the web, and they wanted something that was kind of RPC-ish like. But today, gRPC represents something way beyond what we think thought of as RPC. So I don't know, Jeremy and Eric, did you guys use Corba?
I used like back in the EJB days, like IIOP, which was kind of around the same time, RMI, IIOP with like thick desktop clients to talk to backend systems. Okay. But I wanted to go back a second. Like you mentioned, you're externally facing REST, internal gRPC. I've seen that pattern a whole lot. I actually worked with not on the project, but I worked with the kind of promotion of it, the DataStax folks, the Apache Cassandra guys, that whole Astra as a service, Cassandra as a service, everything there, which is all internal, is all built on top of gRPC.
Yeah, and all the tools, the resume enhancing activity that you might be doing around Kubernetes or something like that, all that internal communication is done via gRPC, and it's so much easier to version and control and work with the performance aspects of it. But I don't know. What about you, Jeremy?
It seems to me most of the people I work with who use gRPC do it for performance, right? REST is pretty easy. It's very easy to get going with, but you're going to get significantly better performance with gRPC, and it's much easier than you think, or it's much easier than I thought when I really dug into it. I jumped a bit ahead just to what RPC means. I want to talk about RPC really quick. If we have people who are younger than that didn't do SOAP stuff or RMI.
Yeah, so SOAP and RMI, and then there was Corba, and for the Microsofties there was COM, DCOM, all that. Those were, COM and DCOM are DCE RPC, and Corba had its own version. What was happening there was you had something called an interface definition language, or IDL, and you defined your data and your functions in there, and you implemented those as interfaces. And then you use this mechanism to do exactly what you see on the screen here, which is this client server model. So it looked like the component could be, basically location transparent to you, but for your code during execution, it looked local, right? So it looked like you're just executing something locally. gRPC provides the same kind of mechanism, but it adds a whole lot of other stuff on top of it that makes it actually usable. So with that, I think let me look at some Java code. What would this look like if we were just doing a basic Maven project? So in a basic Maven project, we're probably going to want to have gRPC installed on something. We're going to show you that you don't need that when Jeremy gets to the Quarkus part. But we're going to define our services in a .proto file, which means protobuffer, and we're going to go into what that means and what protobuf is. That's like our IDL that I just described, or the interface definition for our data and our services. And then we're going to generate the code and then create a client server from that. Today, I think most of the stuff we're going to test with is probably through Postman, though.
Yeah, we'll test with Postman. We've got our code right here, basic Java example. That look at that's okay for you guys.
Now let's jump to the POM file first, because that's right. So with a basic Maven example, if we start with the properties, we have to know what target we're going after for the gRPC and the protobuf, which is the IDL or mechanism. We're going to show that to you in a minute. This, I have a Mac, an M1, and if I did brew install gRPC, it's going to install gRPC and the protobuffers that are the version that you're seeing there. If you scroll down, you're going to see a whole bunch of other stuff that we have to include here also in order to actually get it to work. And then, keep going down. And then eventually we're going to get to the part where we're going to build it. And what this is going to do is it's going to take the contents of this protobuffer's definition file, the .proto file, and it's going to create some generated sources from that. And then keep going down. And the Antler stuff is just going to take the generated sources and make it available to my code. So if we go up and look at the proto file.
So here's an interesting question while you're working. So I see like a bunch of versions and stuff there. Do clients and servers have to be on the same version of protobuf and the gRPC spec?
The protobuffer needs to be compatible. The gRPC versions, that's a great question. I think that that doesn't matter from which it is, but the protobuffers need to be compatible. So I have used newer with older, and there's a bunch of stuff to do breaking changes with versions and stuff. And we'll talk about versioning kind of in the best practices when we get to that part at the end. That's a great question. I've gotten asked that before, and I don't really have a great answer for that. I think
I didn't know the answer myself. I wasn't just trying to prompt you. I didn't know.
No. That's okay. That's a great question. I think
you guys Google it quickly because I'm sharing my screen. So
yeah. So with regard to the proto file, this is all it is. We're just you have a service definition. Unlike other things, what we have here is we're trying to do a little best practice here. So we separate out the request and the response instead of just reusing the same one over again as both the request and the response. Way back in the day of Corba and COM, those were challenged by having stuff compiled into C++, which created an address and memory location. It's kind of similar to this. So when you add elements to the message, you're going to put them in an order and give them a numbering in the order. And that's going to help us later on when we talk about versioning and stuff for the compiled code. So the only thing that the Maven did right now was we set it up with a bunch of dependencies, and then we generated the generated sources.
One thing, this package is for Protobuf, not for Java, so don't rely on that for Java package. If you're using Java, you're going to want to set your own package up here. These other two you can probably live without, but you do need to set your Java package. So let's come over here and page. What we're going to run is Maven clean compile. You notice there's our Protobuf plugins, right? And we succeeded. Let's go over here and look at what we've got. Our target, we have generated sources Protobuf. And so we notice it built out these messages, right? These objects. No, I need to shrink that. Okay. So we can see like a hello reply. Looks like hello reply. hello request. So we've got some methods too. We've got some builder methods and stuff on here. Anyway, so all of our Java objects are created out. So I want to talk a little bit about how we call this. Well, actually, here's how we implement the server, right?
Yeah. Can't see the whole. There we go. So this is just a basic. You're going to notice that it looks a little unnatural in that we have a void when we, right, and that both the request and response are actually in the function declaration.
Yeah.
To me, that looks a little unnatural because I don't like doing that. I'd like to know that it's a response. So when we get to the Quarkus, it's going to look a little more natural. But for all intents and purposes, all we're doing is saying, take the stream observer, add to it, whatever, and then when we complete it, then we can jump out. And that's it. That's about as basic as you can get for a unidirectional call. And this is about as basic as you can get for setting up the main. We can make this much more complicated. Read from a config file, have the port number dynamically added, etc. But for our purposes, we're just doing it all right here in main and saying setting an arbitrary port number. So here, if Jeremy runs this,
we can just run from the IDE. All right, so we started the server.
Yep.
Come here.
So Postman has some really cool feature for gRPC. So he's probably already got, I can't see it, but he's probably already got a collection going, and he can import the Protobuf file.
I'll start from scratch just in case so we can see how we're doing this. We'll say,
Jeremy, can you make the text a little bigger?
I don't really know how to do
Command.
that.
Oh, yeah, there you go.
Over corner. Yeah, right. Okay. So what we come here and do is we click this new,
and then
we'll gRPC.
Yep.
And we'll take service definitions, and we'll import our Protobuf file. Whoops.
Yeah, make sure it's the right one.
Non-Quarkus Java, source, main, proto, hello world prototype. Click next. Oh, I should have given it a name, so now it's just calling new API. That's kind of bad, but in any case, we'll say localhost 899, and it's got our methods already.
Yep.
Also do this kind of nice little thing where message, it'll build a little example message for you, although that doesn't really look so much like a name, does it? We'll say Eric is our guest. So we'll say hello to Eric here. So we invoke that, and then we get down here, we see our message, hello, Eric, right? Which is what we're expecting.
So this morning, Eric, I said something silly like, what did we ever do before Postman? And somebody said, SOAP UI.
Shane is mentioning Craya. Have you ever used Craya?
No.
Yeah, me neither. I've only ever used Postman.
Okay.
Never known Craya, yeah. So if we want to do this, we regenerate, recompile, we can make changes. Right?
Hey, Shane, if you want to put a link in there for us, that would be good. I don't think I've ever used Craya.
I don't think attendees can put links.
Oh, they can't? Oh,
I don't think so.
All
Only
right.
moderators.
This
Craya.
is some homework. We'll figure out what Craya is, right? All right,
Yeah, there you go. Oh, Craya app. There you go.
That's a basic API.
Cool.
Implementation mode.
Right. So that's about as simple as it gets for a. Now, what we haven't done is we haven't talked about streaming and bidirectional, multi-directional communications and stuff yet. But we're going to get into that with Quarkus and show you how that makes life a little easier.
So what makes Protobuf so much faster than REST? Or is that a few?
Oh, that's a great setup, but I wish you had asked that in like a couple minutes because we're going to go into that.
All right, rewind this and
Rewind that part.
Rewind and record over, right?
All right, great.
Basically, we installed Brew installed gRPC. It created a Protobuf file, a proto file, generated. We generated server code, right? Started our server. So what we're going to do next is going to be the Quarkus way of doing this, and we're not going to do so much with configuring the Maven project. We're still going to create a project using either the Quarkus CLI or project generator. Still create a Protobuf file. Actually, I'll grab the same Protobuf file, and then we just start the app. And so that's what we will do for.
So do you want to go to, the code dot, actually show them, where we generate the Quarkus code from?
Yeah. So start with that. We can do code.quarkus.io.
So here,
actually, we should show where's Protobuf.
Go ahead.
Protobuf.dev. In case you want to dig into more of this, and there's links at the bottom of these slides. The documentation for both Protobuf and gRPC is, I think it's IO, right? gRPC.io.
Yeah, it's really good.
Yeah, excellent documentation for all this stuff, right? So you can come in and clone projects and get started pretty quickly.
The same with Quarkus.
Yeah.
So here, I think what we're gonna do is use the default one at the top, the rest easy one, but there's options for gRPC also.
Yeah, so there's all kinds of stuff that we can use.
Yeah.
I'll create it from the command line, and then also if you go to Quarkus.io, and you look on the Quarkus documentation or guides, if you just come to gRPC, there's really good stuff here. Getting started, implementing service, consuming service, some other stuff in here too. So really nice documentation. So let's come over here. I will go to this tab, and I'm directory is in a gRPC directory. I'll say Quarkus create app Red Hat dev corner, and we'll call it dev corner.
So what Jeremy's using is the Quarkus CLI from here. This is another way to create the app. If you had done it through the browser, you download a zip file and you can just unzip that in whatever directory you want.
Or it'll push it to your it'll push it right to your repo. And then I did not add the corner Quarkus gRPC June. I can also add my extension, so Quarkus ext add, and I need rest easy reactive and gRPC.
Cool.
All right, so then we've got our stuff right here, and let's open up IntelliJ. Actually, I've got IntelliJ open. I'll just go ahead and import it as a module into this one. So I'll say file, new module from existing sources. First corner, gRPC June. Open that up and import that from Maven. All right, so now let's look at this file. So go into the presentation mode too. All right, so the first thing we'll notice in the POM file is there's a lot less in the POM file, right? So if you remember all the stuff we had in there, this looks like just a regular Quarkus app. We define Quarkus platform and a BOM. It's kind of, right? There's really nothing special going on there. And of all the dependencies we need to bring in, there's really nothing that's not kind of just Quarkus gRPC, right? That's all we need. I haven't installed Brew on my system. I mean, I haven't installed gRPC in my system, so it's all going to be handled by Quarkus here. So we come up here. We are going to need to create our proto file, right? So create directory, call it proto, and you know what? Let's just copy the one that we have here. Course proto. Copy, and we'll just paste that here. Paste. So we've got, and I'm going to change this to what we change to Red Hat. Right, so that's our package, right? Com Red Hat Dev Corner. Yep. These example things here, and just get these out of the way. All right. So first thing we're going to need to do is implement our server like we did before. We have a Java class here, and we'll call it I'm going to call this a mutiny server. And the reason I'm going to call it that is we're going to use Quarkus. Quarkus has, under the covers, Quarkus is reactive. You can do either imperative or reactive programming with it. The imperative programming is going to look essentially exactly like what you just saw with the other Java example. So this time I'm going to use reactive, which I think looks a little bit nicer. There is a bit of a learning curve to reactive stuff. Actually, I'm going to need to build this first. Let's say here, say Quarkus build. So I'll run Quarkus build, and this is going to generate all those classes for me. So you notice they've got a generate code going on here. Generate code, right there's going on. So we look over here. In our target, we have generated sources, gRPC, and Quarkus made a lot of decisions about this code. First time you generate code, you need to tell your POM IntelliJ that you did that. It picks it up on subsequent changes, but first time you do it, you need to tell Quarkus. So the core entry point into what it generates is the greeter interface. And it's got a couple for you already, greeter gRPC, and this is going to be the basic Java one. You can extend that class, or you can use a mutiny greeter gRPC. We're a little bit more interested in the mutiny one. We're going to implement our own greeter. So let's come here, and we're going to say implements greeter. And it knows something's wrong, right? So it's going to say implement methods, implement our method, right? What we're going to need to do here is we're going to return a uni. So I mentioned that we're using the small library reactive library, and small library uses two concepts: uni meaning a single result, or multi meaning multiple results. And then you combine that to get mutiny, right? So uni create from item, and we're going to say.
So just to kind of interject a little bit, so multi isn't necessarily multiple items. It's more about being an unbounded stream, or an unknown or undeterminate number of items. So, which is kind of a difference from other frameworks that are out there where, usually you would use like singletons and multiples, but the behavior is a little bit different.
Yeah. And so remember, we need our hello request, right? So we're going to say hello request, and it has a method called new builder. And we're going to set name. It's going to be our request at name. And then call build on that. And when I'm returning a hello reply, I can return the hello reply, or I can return a string. Why is it mad at me right now? Mad about say hello right there. Okay.
Yep, we need one more parenthesis, close parenthesis.
Oh, why is it getting mad at me? I need a uni, and this is a uni hello reply. So oops.
So you've injected the same class into itself. Like, I'm not sure what you're trying to do.
I'm going to cheat 1 second. Because I just messed up my code here. So rather than make you guys watch me struggle with this, let's. All right, so what we're doing, we're creating from an item. So we're creating a single result from an item, and that item is going to be a call to new builder, set message, hello, request. So we're going to hit request, and then build a request, right? And the request we're going to build is hello, I'm going to say from mutiny, so we can tell it's different from the last one. All right, so let's come up here and start this up. I'll say Quarkus dev. Oh, whoops.
You're injecting the same class as a sub-service. You got to get rid of that.
Oh, yeah, whoops. Thank you. You told me that a second ago, didn't you? All right, there we go. And so we are running, and we can come here. Well, let's just swap this out to localhost 9000. Say hello. Hello, Eric from Mutiny. So you guys can see that now. We've got hello, Eric from Mutiny. If we want to change this, we can say, you know, Mutiny says hello. Name, come back, and it runs really quickly, right? So same as you're used to using Quarkus. If you used Quarkus development mode before, right, we can make changes, and it recompiles, and it's running pretty much immediately.
So there's an interesting question. Some Nani or Nani, I'm sorry if I mispronounce it. What's the difference between gRPC and Apache Kafka in order to, I would think, achieve scalability and durability? So I think like gRPC is the protocol or is the communication mechanism, and Protobuf is the format of the messages, right? Which you can use in Kafka. You can use Protobuf as a message format in Kafka.
Yeah, I think a significant difference here is in a previous episode we did a talk about basically loosely coupling things, and Kafka provides us the ability between microservices to more loosely couple our services. So if we want to do some design patterns like BFF or things of that nature, and more loosely couple our services, you are going to have coupling with gRPC. So this is more where you want performance. You're not so concerned about the coupling between things because the client and the server actually are acting like they're calling each other natively, even though they're not, and they're distributed. But Kafka is, I'm going to put a message someplace, and other people are going to read that message, and they're going to act on it, and they may put a message in return for me, which I might have to wait on another channel. But
yes,
yeah.
So yeah, there'd be three things in here. Like in our example, we're running this client machine is Postman, right? And the server machine is Quarkus, or that other Java one we built, and they're talking directly to each other, right? So Postman is making a call to Quarkus the same way it would a web server, right? And then Quarkus is sending back the response. So it's similar. It's just like a web server works. So, if you're calling, Quarkus or Tomcat or Spring Boot, except that you're using a different protocol besides HTTP. Actually,
yeah, and this is it's also a binary protocol, but from it is the difference between using messaging versus an RPC mechanism, which is basically a direct call with an open channel.
And so what we'd see if we were using messaging, you'd have a third thing down here that would be Kafka, and this guy would write to Kafka, and then this guy would read from Kafka, and then this guy would write to Kafka, and then this guy would read from Kafka.
Shane online said it more eloquently and in less words than we all did. So
it's more point to point, right? Just like you would kind of like you're swapping out the underlying transport mechanism, but you're still doing point to point communication.
Yeah.
Yep, point to point. And let's see if we wanted to do a consumer too, we could say, Mutiny can REST. We put a REST API over on top of it, right? You can say like hello gRPC. Say get public string say hello. Say that.
And so while you're typing, another question, like how does the gRPC APIs work with like front-end UI frameworks like Next.js or Angular? They don't, right?
I would say don't. Now you can generate gRPC code or from proto files for JavaScript. Think of it on the back end. All our browsers support HTTP2, but you're not going to be able to support gRPC from a call from some front end. What it's going to have to be is some back end server side JavaScript code. So more like a Node.js kind of thing on the back end, but not from stuff that's actually running in the browser.
whoops.
Now, where there might be some differentiation with that is, could I open a channel, say, from WebAssembly with gRPC? And that's a different beast altogether we can talk about later.
And Jeremy, you got to transform a hello reply to a string.
Right. So what we're doing here, what this says is I injected my gRPC service. This is where I needed to inject that, not in the actual service. Yep. So I injected my gRPC service. This is just a REST API. And then what I'm doing, I'm getting one response. It's a string, and I'm going to call this method, say hello. I'm going to grab a query param called name, and then I'm going to call this server, right? And call that method say hello. And this is like, instead of calling like a URL, right? We're calling the actual method on the server, because I can see the server and I'm sending over the actual object built from the Protobuf message. And this is just the hello request new builder set name build. It's the syntax it uses to create the request. And then from if you haven't seen reactive stuff before, what I'm doing, I'm calling this an on item, meaning when I get that hello reply, I'm going to transform it. What I'm transforming is I'm just pulling the message out of it. So I send the string directly, and I'm already running, server's already running. So to be able to do this, we can say new HTTP request, and we'll say localhost and hello gRPC, and we'll say his name is Rob. So let's see what happens here. And what you have here is Mutiny says hello Rob. So that's what we've got from our message. We can watch, we're just calling that, that's coming from the Mutiny server, right? So we can just change, we can change that too, right? And just say, hello, Rob, it'll pick it up really quickly. Hello, Rob, right? So we change that very quickly. So this is how you write a request. And this would be the same, like in a REST framework, we would just be calling an endpoint, right? We'd use a REST client. We're not using a REST client, we're using a gRPC client, right? And so we have our gRPC client right here, gRPC service, and we're using that to connect to the server. All right, let's go back to our slides now. We'll come back and look at some more code too in a moment.
Motion detected at the front door.
All right.
Oops.
Somebody's getting a package.
Sorry,
somebody's getting a package.
Someone in my house.
Not me. All right.
All right.
You never know what's going to trigger your Alexa to start talking.
Yeah, exactly. Oh, order some toilet paper for Eric. So, all right. All right. I guess we want to talk about gRPC again. So what actually, you asked that question earlier, Eric, you know, what makes gRPC a little more special than RPC? So let's start with HTTP2. HTTP2 is supported by all the browsers, but as far as that goes, it came out in 2015. It's probably more popular than HTTP 1.1 right now, which is, you know, where we think of mostly REST based. But what makes it different is you can start with the the binary framing layer. So with regard to that, HTTP2 request response is kind of divided into these like small messages and framed in like a binary format, and that makes the message actually more efficient. So binary framing allows the request response multiplexing also without blocking network resources. Maybe if you want to go on to the next one, I'm going to zoom through some of these so we can get back to the code.
Okay.
And one of the things that enables is a header compression is also part of HTTP2. So everything in HTTP2, including headers, is encoded before sending, which significantly improves the overall performance. And it uses this compression method called HPACK, so capital HPACK. And HTTP2 only actually shares the values that are different from any previous header packet call. So what this is demonstrating is that if I change something, it's only going to actually send me back the changed thing. So that also improves performance. Okay, so something that we kind of skipped over really quick, but that's okay, is there's other HTTP2 concepts like streaming, flow control, and processing. We don't need to get into all those, but that also enables other performance and mechanisms. And can control like buffers and flight sizes for in-flight messages, etc. But this thing, protocol buffers, which we've been using, is really the IDL language, the description language. So it helps control the serialization and deserialization, and enables us to define services and then auto-generate those client libraries. So as we noticed, everything is defined in that .proto file. And then what we did was Protobuf provides a compiler called Proto-C, which is, or Protoc, depending on how you want to pronounce it. And that compiles everything that's in that proto file into code that, we can use in memory at runtime, and allows us to serialize and deserialize into this binary format. And then, parsing with Protobuf requires fewer CPU resources because it's not converting text like we do with like JSON and stuff. It's actually in a binary format. So if you want to go on maybe to the next one, and then let's go through the next couple, and then we can jump into
the next. Oh, sorry.
Yeah, that's okay. So jump down. So what are some of the, yes, go back one. Yeah, go back one. Nope, the one that you had with advantages.
What?
I don't know how you're running the show there, Jeremy. So
sorry, which
the one that said advantages. You had it a minute ago. Yeah, right there. Up.
Right here?
Nope, up. We're gonna do that in a second. Scroll up. Keep going. Keep going. There you go. Right.
Okay.
Let's talk about that for a minute. So rather than show you a ton of slides, we're just going to talk about it on one slide. Eric asked about performance. So I just told you a bunch of reasons why it's more performant, but what can we expect? So results may vary, but generally over a RESTful plus JSON call, you're probably going to get some close to 10 times the performance out of it, Eric. It's just, add all those other things that we talked about together. Protobuf serializes the messages on the server and client sides. It's smaller, more compact payloads. We can do multiplexing, eliminating head of line blocking. We can do compression, faster loading, but it's in binary format. So we're going to talk about that. With some people don't like that because they like to see their JSON. Streaming is another thing. This enables streaming. So Jeremy's going to get into some examples here, but we have unary, which we already demonstrated. That's actually no streaming. Then there's client-server streaming, server-to-client streaming, bidirectional streaming, code generation comes along with that, and interoperability as part of code generation means that we can support Java, JavaScript, Ruby, Python, Go, Dart, Objective-C, C#, Rust. I've recently done some Rust with it.
I knew you were going to throw Rust in there at some point.
I had to throw Rust. So I moved on from Camel in every conversation to Rust now, Eric. So
Rust fixed Ruby this year, apparently, according.
Yeah, Rust and WebAssembly are my new favorites. So
don't invite me to that talk.
Oh, you want to come to that one? Yeah.
No, I don't want to come to that one. The WebAssembly.
Oh, you don't want to come to that one? Okay. You can go on. Let's go over the comparison really quick with Rust, and then go back to code, because we really want to get back to code. So what are the differences here? Standardization versus no standardization. With REST, you can say you're doing something standard because you're doing open API, Swagger kind of thing, but really that's not part of the standard, right? There's no standard. There's REST is just something, using resources, right? And I'm going to create a standard maybe within my organization to use certain tools in order to help me with that. But at the end of the day, there's no real standard. And gRPC brings a standardization process to this. Paradigms, we've already talked about RPC versus resource-based. Service modes. Well, I just said gRPC can do, client streaming, server to client streaming, bidirectional streaming. Really, REST is unary only. From other kind of requirements, REST is HTTP 1.1, and typically we use JSON over that. I guess you could use XML for those people coming from maybe a SOAP background or something. I'm sure there's quite a few people still doing both SOAP and JSON for some reason. Let's see. From a design perspective, as an architect, it should be, design first, but really REST is really a code first kind of experience. I know that you might be able to argue that because you're using certain tools, but in practicality, you have to do design first with gRPC. Anything I'm kind of missing?
Yeah, I don't know that I necessarily agree that API design in REST is always code first, because you can do Open API and there are plenty of tools out there that can generate your REST endpoint
Sure.
from various frameworks.
But it doesn't require, the framework, REST itself doesn't require to use those tools. You and enforcement within your organization require that. And there's no standard to what that looks like. So, post, get, all the verbs there, you could use those wrongly. And we talked about how we think you should use them properly in our last talk, but people use them incorrectly all the time. Look at the variability with versioning, right? With REST
versus camel
case. You could put it in the URI, you could put it in the media type, and if you don't put it in the media type, that's going to close you off from doing, Heyday OS, right? So, there's consequences to that, and there's no standard to that, is I guess what I'm getting at.
Okay.
So I'm arguing with you because I want you to argue back.
No, and that's kind of why I brought it up, because the determination of where you're talking about this chart here is from the I want to build an API. Like you said, you could do code first, you could do contract first, but there's nothing in REST that says which way is better, which way, it's completely up to you.
Yeah, it's
gRPC, you're
completely arbitrary. Yeah.
And in gRPC, you're absolutely going to do a contract first. Right.
Yeah, you have no real choice but to do contract first in gRPC.
Yeah.
Anyway, all right, let's jump back into some code and actually see some of those things we just talked about. So,
all right, we're running tight on time. So you know what I'm going to do? I'm going to add several methods at once, maybe, instead of just. So what we can see here, let's go back to our presentation mode, or maybe I'll add several, maybe I won't. RPC.
While he's doing that, I don't want to imply that our gRPC is the cat's meow of everything versus REST. What I'm getting at is use the right tool for the right reason. REST is still the public-facing API for most things, right? And internally, you're going to want to do event-driven things to decouple your code, especially in microservices environment. But gRPC is a natural way to go, especially when you're doing that decomposition first and you're doing component, separating things out into components.
And so what I do here is I now have this say hello several times. I'm sending over one request, right? We'll do the same thing. We'll just send over a name, but I'm going to get multiple replies back based on this, right? So I'm going to return a stream of hello replies. And if we come over here, and
you got to regenerate.
Didn't have to. Did I turn the server off? There we go. So we successfully finished generating proto files. So one thing, Quarkus in dev mode watches your code, notices our code has changed, and it notices I am now no longer correctly implementing greeter, right? So implement greeter object, and now I have to say hello several times, right? So
yeah, if we were in that other Maven project, we would have had to stop the server, recompile, and then start it again after we coded everything up, right?
Yes. Create from going to create this from an multi is multiple things. So we can create this from, one of the things you can do is create it from an is from an iterable object, right? So for an iterable object, what I'm going to do, I'm going to get a hello request, and I am going to say raise as list.
So while you're typing, I think one interesting, and whether you may have already done this or not, but maybe a follow-up webinar or whatnot would be, how do you some practices and tools for sharing these, because this is your Protofile is essentially a contract. Anybody who's talking on that service needs to have it, the tools and techniques and practices for sharing and versioning and all that
stuff. And there's going to be, it's not, so when Eric says sharing, it's also about not just sharing between the two projects like we just did, a single Protofile, but some, Protofiles can include Protofiles, right? And, we might have other definitions that we want in there.
Yeah. So there's a question that came in, does 3Scale support gRPC APIs as a backend? And if yes, does it show up in the developer portal? I have no idea.
Wow. Okay. We would have to find that one out. I'm not that familiar with 3Scale. That's the API management tool, not to be confused with like an API registry. So we also at Red Hat anyway, we have a API registry based on API Curio. So if you went to the API Curio website and you want to author, say that Open API kind of thing, from that perspective, there's also a registry that you can run. And the registry does support gRPC, GraphQL, REST, and JSON, and a couple other things, doesn't it, Eric? I'm pretty sure it does.
Yeah.
I know it does gRPC and REST, and it does Kafka too, right?
Yep.
To me, internally, that's where you're going to want to find, do some service discovery. So maybe we should do something that incorporates that on one of our subsequent sessions, because we can run that locally in Docker, I think.
Yeah, so like between like Epicurio and Microx and whatnot, you get a bunch of decent tools.
Yeah, exactly.
We just put the hello. Man, I'm sorry. I'm making a mess of this today. So.
Wow, and you're in London, and you have is it almost? It's like later in the day, so it's almost like beer time over there, right? Maybe that's the problem.
Yeah, everybody is already.
Beer time has already passed.
Oh yeah, shut it.
Looks like it. So all right, so what we're doing is I just created a list of some compliments that we will add to our response. I'm streaming those, and then which is just like pulling all these out. This is just regular Java stream, right? And I'm mapping each of these to a new, taking the string there and mapping them to a new hello reply, right? Because I want a bunch of responses. I want to send multiple hello replies back over the wire. And so what I'm doing is the new builder, hello reply, new builder, we saw this a minute ago, right? It's the same thing we have up here. Hello reply, new builder, and a request get name plus S, right? So I'm going to say, and we can add in like a hello here too as well. Hello, hello. Let's get name plus S. Build that, and then we collect and to a list, right? And so what I'm returning is going to be a multi, right? Because a multi comes. You can create the multi from an iterable, and a list is iterable. So let's look over here at what we've got. Let's, we're gonna have to have a new new gRPC, and I think I'm gonna need. I don't import a Protobuf file. We are in gRPC, and we are in June. Source main proto. Next, we can give it a new API. So we'll say for gRPC. All right, and then message again. We can click example. Local 9000, and we got our say hello several times. It can give us an example message. We'll say hello to Eric. So what happened here now we can see is Postman will tell us at the bottom, we sent one message, right? So sent request to 9000, name Eric, and we received a response. We received 3 separate responses. So we say, hello, Eric, your wit and wisdom are apparent. Hello, Eric, your experience is awe-inspiring. And hello, Eric, your skin tone is fabulous. Right? So we had multiple messages with some nice little compliments. The reason we're getting this message here is because we are returning the hello reply. If we wanted to change this to returning a string, so let's see, we could say string, and we could actually, no, I'm sorry, I wouldn't do that right there. We have to return a hello reply because we're here strongly typed. If we call this from our consumer, we can then turn that into a string. So let's come back over here, take a look at our REST API, right? So if we wanted a REST API, we can return a string. Like we are to Uni here, we can do the same thing. We would just transform each of those and add a transform, return strings.
So there's a question that says, have you observed any issues with Quarkus native build of gRPC API code versus the UberJar build?
No, but to be honest with you, I don't have experience using UberJars very much at all. So
yeah.
Yeah, I know that the Astra folks, I think they're doing mostly native, but I could be wrong. And I know there was I want to say it was the logic drop. I think I could be mistaken, but I think logic drop is a blog post on the Quarkus.io about it. I think they're doing a lot of gRPC with native as well.
Yeah.
What we'll do here is we'll get multiple requests and have one reply. Let's go ahead and add these in here too, like just do them both at the same time. And then say hello back and forth, and we'll stream both of these. And all right, so when I say that, we will figure out, Mutiny server will in one moment anyway, or so figure out code. Where's our corpse code?
I don't think we're going to have time to get to it, but while he's doing that, we talked a little bit about microprofile here. One of the things, with microprofile is like adding, open telemetry kind of things. The classes that Jeremy has here, we could simply add some of the annotations for, some of the open telemetry and get information from that, adding microprofile to these. I don't know, Eric, if you want to add anything to that.
I'll grab my cheat codes. We're running out of time here. So, yeah, what you do, the way you say hello one time, which to look at this is we take the request. When we get the item of the request, we call this method request get name, collect those into a list, and then we turn all of those into a long. We take all of those as a list, right? So we've collected all of the strings as a list. We then take that and call a string join. So we're going to join all the names that we get. So what it's going to do is it's going to open up a connection. It's going to listen for multiple requests. Once the connection's closed, it's going to stop and return this one message, right? So we want to look at what that looks like.
And thanks, Eric. I know you got to drop. Thank you very much for joining us today.
Yeah, and, unfortunately, I do have a hard stop at the top of the hour.
All right. Anything that goes bad after you drop, we're definitely going to blame on you. So
of course,
have
wouldn't
fun.
want it any other way.
Thanks, Eric.
Say hello once, and message will say. All right, so Eric just left, so we won't say hello to him, right? So we'll send that, and so we just sent this. You notice it says end streaming here. That tells us our connection is still alive. Who do we have? Anybody? Who do we have listening online?
Yeah, there's still.
Caroline is probably our producer. Caroline, our producer.
Caroline.
There you go. All right, and then we end the stream, and then we get back one message. Hello, Rob, Jeremy, Caroline, our producer. Right. So what it does, it opens up this connection, waits for all these, batches it, right, does some processing, and then sends it back to us. And if we implement this last one, we'll take a quick look. What this one, this say hello back and forth. What we're implementing here is this one. We're going to stream on both ends, right? So bidirectional streaming. We're going to get lots of requests and we're going to send back lots of replies, right? What we're doing is we're getting the request, same thing, we're calling get name off of that request. We're transferring that to your friendly stream says hello plus your name. When we get that, we then take that message and we create the hello reply, right? And then send it back. It's going to send it back and forth. So let's come over here and see what this does. And we'll say, whoops, we'll say hello to streaming. And we'll say, and oops. Oh, say hello. I named it something different this time. So it's the way you change your servant different. So I need to import a new file.
Re-import the proto file.
Yeah, I need to re-import the proto file because I changed the name. It's different. What do we call this?
You don't need to click on it. You don't need to click that.
Yeah, I can skip that. All right. Import.
Yep.
And now we'll send message. We'll invoke that. Okay.
Oh, the name.
Say hello back and forth. Yep. Invoke. So send. And so we notice it came back immediately, right? But it says end streaming. So we still have a connection going on, right? It's just going back and forth, right? So if we're we're running a chat bot effectively, right?
Right.
But my connection's still in place. Connection doesn't terminate until we click end streaming, right? And then call's completed. Cool. There's some really nice stuff inside of Postman for using this. Postman, the more I use Postman, the more I like Postman.
I know.
All right.
Yeah, so your screen is a little blurry again.
Sorry.
Yeah, I don't know why.
All right, let's go over here. There's some really good material.
It's still a little blurry, Jeremy.
Still bad?
I thought it was my eyes, but
do you want to try to share instead of me?
No, that's okay. Yeah, we're going to go through this pretty quick. So the goal here is just to give some best practices, and then we'll close it out in a couple minutes here. So if you don't do anything else or take anything else away, use the style guide. We'll post the a link to the presentation. You'll get the links here, but definitely look up the Protobuf style guide. There's some excellent linter plugins like for IntelliJ and VS Code. Definitely look at the style guide for naming conventions and stuff. Keep going. With regard to this, really, what do I have to say about this is definitely separate your requests and your responses. And the reason is if you try to use the same one in both, what you're going to wind up in a problem state sooner or later where you want to add something to the request, or you want to add something to the reply, or you want to remove something, and then they don't match anymore. So you're going to get in trouble if you do the first line on the create order thing there. And with the enums, because it is cross language, you also have to take into account that other languages are going to see enums differently. So C# has some wacky things like removes the prefixes. C++ doesn't see enums the same way. So definitely look at making sure your enums don't have name clashes across enums too. So if I had two enums that said medium in it, that might clash in certain languages when it generated the generated code, right? So try to make them unique, right? Regarding well-known types, Protobuf comes with a bunch of well-known types out of the box. Timestamp is one, any's another one, empty is another one, and then those kind of come out of the box. It also has some pretty interesting definitions for proto definitions for things like money and other abstract items like that too. So what I would recommend is probably try to use the things that are out of the box instead of reinventing the wheel there. Keep going. Versioning, this one's really interesting because it goes to great lengths to try and make sure that backward compatibility is maintained. So there's rules for anything, but non-breaking changes, you can even delete some old, some fields, but that could also create backwards compatibility problems. But binary breaking changes are a little different. So renaming a message, nesting, unnesting messages might have consequences in particular languages, like things in .NET with C# versus Java or C++. So you do have to be aware of what you're, what is a breaking change, and the documentation that Jeremy pointed to in the very beginning is really good. I would definitely go there about looking at versioning. Optional fields. The really cool thing here is this thing at the bottom called the field presence tracking. What that means is that is the default value, if it's optional, is it go to a default value or not? And that, again, is going to be different based on different generated languages. So, what we want to have is the same default value. So definitely look at, optional fields, because not everything is nullable the same way in every generated language. So keep going. One of, this is, exactly what it means. It means that, when I put one of in there, I only have one of those orders in there. Keep going. Yeah. Large messages, the default here is now we're into gRPC with large messages. This may, I would avoid this in garbage collected languages, and stick with the default message size, so which is 4 megs. So consider streaming, splitting the payload up, etc. If you have really large messages. Also, from a load balancing perspective, gRPC runs in layer 7, not layer 3, so it's not the networking, from a networking stack perspective. And this allows me to do some really cool things like client-side load balancing, where I can retrieve a list of my known endpoints and then load balance from the client. Definitely reuse channels. Channels are opened, and we know that channels are expensive to create. So keep channels open as long as possible. HTTP2 has a keep alive period. So after a certain period of inactivity, it'll shut down a channel, and you're going to have to make, explicitly keep those channels open. So if you're not using like Quarkus or something, you may have to actually insert code that keeps those channels open. And max concurrent connections. This is just like a web server, that has threads on the back end that says I can handle a certain amount of requests. So the max concurrent streams out of the box is 100. Everything's configurable that we just talked about, but I like to stick with, what you get out of the box, so you don't have to deal with all that stuff. And that's about it. So when we put out these slides in a PDF, there's going to be a bunch of links here to some really good resources from other folks here at Red Hat who've written about gRPC. And Eric D'Andrea, who joined us earlier, has written a couple of them.
And
Sorry,
he and this guy, Kamanas Kafi, built a really nice demo.
Yeah,
gRPC.
Very nice.
All right, well,
that's it. So thank you everyone for joining us today. Sorry we went a little bit over. And I hope everyone has a great rest of their week. Thanks, Jeremy.
Thank you. Thanks to everybody who joined us.